Welcome to IrisLogic's YouTube channel. Today, we're diving deep into the world of AI and machine learning to understand the backbone of these technologies' algorithms. In this video, we'll be shedding light on a fundamental aspect of the tech industry: algorithms in AI and machine learning. From Google's search engine to YouTube's video recommendations, algorithms are everywhere, shaping our digital lives. Yet, they remain enigmatic to many. Today, we aim to demystify algorithms and explore their significance. To begin, let's understand what algorithms are. In basic terms, an algorithm is a set of solidly defined steps which need to be taken in order to reach a planned result. In particular, it is used to solve mathematical equations. It can be broken up into three broad components: input, algorithm, and output. Input means the information you already know at the beginning of the problem. Algorithm means the sequence that needs to be followed step by step to achieve. Output means the expected results if all steps in the sequence are followed to the letter. How do algorithms work in AI? Fundamentally, artificial intelligence, AI, is a computer program. Meaning that, like Firefox or Microsoft Word or Zoom or Slack, any AI or machine learning, ML, solution you come across will be built from the ground up with algorithms. What algorithms do in AI, as well as machine learning, is variable. Broadly speaking, they define the rules, conditions, and methodology an AI will use when processing and analyzing data. This can be as simple as defining the steps an AI needs to take to process a single invoice to having an AI filter out pictures with dogs among a dataset containing hundreds of thousands of pictures. Algorithms in machine learning help predict outputs even if given unknown inputs. AI algorithms function similarly by solving different categories of problems. The types of problems that AI algorithms solve can be divided into three broad categories: classification, regression, and clustering. Classification means a type of machine learning which is used to predict what category, or class, an item belongs to. Regression means a type of machine learning which is used to predict a digital label based on how an object functions. Clustering means a type of machine learning which is used to sort objects into groups based on similarities in their functionality. The types of popular classification algorithms are binary logistic regression, naive Bayes, k-nearest neighbors, decision tree, and random forest. Binary logistic regression can predict a binary outcome, such as yes or no or pass or fail. Other forms of logistic regression, such as multinomial regression, can predict three or more possible outcomes. Logic regression can often be found in use cases like disease prediction, fraud detection, and churn prediction, where its datasets can be leveraged to assess risks. Naive Bayes is a probability algorithm built off of incorporating independence assumptions into its models, meaning it operates off the assumption that no two measurements in a dataset are related to each other or affect each other in any way. This is why they're called naive. It's commonly used in text analysis and classification models, where it can sort words and phrases into specified categories. While also sometimes used to solve regression problems, KNN is most often used to solve classification problems. When solving classification problems, it separates data points into multiple classes onto a plane to predict the class label of a new data point. The new data point is given a new classification based on which class label is most often represented around it on the plane. KNN is also known as a lazy learning algorithm, which means it doesn't undergo a full training step, instead only saving a training dataset. A supervised learning algorithm, decision trees, can also be used for either classification problems or regression problems. It's called a tree because it possesses a hierarchical structure. Starting with a root node, it branches out into smaller internal or decision nodes where evaluations are conducted to produce subsets, which are represented by terminal or leaf nodes. Random forests leverage the output of multiple decision trees to produce a prediction. Like decision trees, random forests can be used to solve both classification and regression problems. Each tree is made up of a data sample drawn from a training dataset that uses sampling with replacement. This adds randomization to the decision trees, even if they draw from the exact same dataset. In classification problems, a majority vote is determined from the output of these randomized decision trees. Some examples of regression algorithms used in AI and machine learning: linear regression, Poisson regression, ordinary least squares regression, lasso regression, and neural network regression. An algorithm with use in both statistics and the social sciences, linear regression is used to define the linear relationship between a dependent variable and an independent variable. The goal of this sort of algorithm is to determine a possible trend line with the given data points. Businesses often use linear regression when determining how revenue is affected by advertising spending. Poisson regression is a type of regression where a predicted variable is always assumed to follow a Poisson distribution. A Poisson distribution is a probability function that can help determine the probability of a given number of events happening within a specific, fixed time period. One of the most popular regression algorithms, OLS regression, takes ordinal values as input to determine the linear relationship between multiple variables. The algorithm is most useful when predicting the likelihood of something being ranked on an arbitrary scale, such as how likely a game is to be rated a 7 on a scale of 1 to 10. It's often used in the social sciences, since surveys in that field frequently ask participants to evaluate something on a scale. OLS regression is also known as ranking learning. Lasso regression takes an OLS regression and adds a penalty term to the equation. This can help you create a more complex representation of data than is otherwise possible with simple OLS. It can also make the representation more accurate. Lasso regression is also known as L1 regularization. Neural networks are one of the most popular methods of AI and ML training out there. As the name implies, they're inspired by the human brain and are great at handling datasets that are too large for more common machine learning approaches to consistently handle. Neural networks are a versatile tool and can perform regression analysis as long as they are given the appropriate amount of prior data to predict future events. Some examples of clustering algorithms used in AI and machine learning: k-means clustering, mean-shift clustering, density-based spatial clustering of applications with noise, balanced iterative reducing, and clustering using hierarchies in Gaussian mixture mode. An unsupervised learning algorithm, k-means clustering, takes datasets with certain features and values related to these features and groups data points into a number of clusters. The K stands for the number of clusters you're trying to classify data points into. K-means clustering possesses a number of viable use cases, including document classification, insurance fraud detection, and call detail record analysis. A simple, flexible clustering technique, mean-shift clustering, assigns data points into clusters by shifting points toward the area with the highest density of data points, called a mode. How a cluster is defined in this setting can be dependent on multiple factors, such as distance, density, and distribution. It's also known as a mode-seeking algorithm. Mean shift clustering has uses cases in fields like image processing, computer vision, customer segmentation, and fraud detection. Density-based spatial clustering of applications with noise separates high-density clusters from one another at points of low data point density. Netflix's movie recommendation algorithm uses a similar clustering method to determine what to recommend to you next. For example, if you watched the recent Netflix movie Do Revenge, the algorithm would look at other users who also watched Do Revenge and suggest movies and shows based on what those users watched next. Discan is excellent at handling outliers in datasets. Viable use cases for Discan include customer segmentation, market research, and data analysis. Balanced iterative reducing and clustering using hierarchies is a clustering technique often used for handling large datasets. It can scan an entire database in a single pass and focuses on spaces with high data point density within the database and provides a precise summary of the data. A common way to implement Birch is to do so alongside other methods of clustering that can't handle large datasets. After Birch produces its summary, the other clustering method runs through the summary and clusters that. As such, Birch's best use cases are for large datasets that normal clustering methods cannot efficiently process. Gaussian mixture model, much like Poisson regression, utilizes the concept of Poisson distribution. GMM models datasets as a mixture of multiple Gaussian distribution models. Gaussian distribution is also known as normal distribution, and as such, it can be intuitive to assume that a dataset's clusters will fall along the lines of a Gaussian distribution. GMMs can be useful for handling large datasets, as it retains many of the benefits of singular Gaussian models. GMM has found use in speech recognition systems, anomaly detection, and stock price prediction. Choosing the right strategy or algorithm for your AI models is not a trivial task. IrisLogic teams of data scientists and engineers that can help you build your AI and ML strategy. Our team can cloud host such models, regularly conduct data ingestion, extract and transform data, execute and improve models, continuously monitor progress, build impressive data visualization, and prioritize machine learning models per your business requirements. We have engaged with top-tier and startup companies to help them plan, proof, and execute machine learning algorithms and AI strategy that fundamentally improved their business outcomes. Contact us today.